Hello everyone. Here we have measures of position and outliers. Okay, and this part we have z-scores. So what z-score is, z-score represents the distance that the data value is from mean in terms of number of standard deviation. So this is number of standard deviations from the mean. Okay, the first one here on left is population z-score. Since we have population in denominator, we have sigma, and that is for population standard deviation. And on top is x minus mu mean, and this one is population mean. So that is population mean. And here this part is population standard deviation. Here on this side, this x bar is sample mean. And here S is sample standard deviation. So for both of these, we have exactly the same thing. Z-score is equal to x, which is our data value, minus mean divided by standard deviation. So here, this x is data value, and same thing on that part. So these two are data value. The point is that the z-score is unitless. What that means that mean is 0 and standard deviation is equal to 1. In 2010, babies born after a gestation period of 32 to 35 weeks had a mean weight of, we have mean as 2,600, and standard deviation is 660. In the same year, babies born after a gestation period of 40, so that was 32 to 35. This was for 32 to 35, and here we have 40 weeks. So they had mean of 3,500. Standard deviation is 470. Suppose a 34-week gestation period baby weighs 3,000, and this is for 34. And 40-week is 3,900. Yeah, what is z-score for 34-week, and what is z-score for 40-week? Which baby weighs less related to the gestation period? Okay, so I'm starting with 34 because here, okay, it's asking for 34 and then 40. That's how I'm going to write 40-week. Okay, so what's given for 34 mu is or mean is 2600, as this one, because 34 is here in this period. Mean is 2600 and standard deviation is 660. So for the sport we have these two. Now finding z-score. So z is equal to x minus mean divided by standard deviation, and that is equal to we have these data value for 34-week period. Baby weighs 3000. So x is 3000 minus mu is 2600 and standard deviation 660. This is 0.61. And that's all for 40-week. What mean and standard deviation is. Mean is 3500, standard deviation is 470. Now finding z-score. And for 40-week period, baby weighs 3900. This is x minus mean is 3500 divided by standard deviation 470. Okay, running that, the answer is 0.85. Okay, so we answered the first and second part of which baby weighs less, comparing these two z-scores. This one that we have here is has lower z-score. So 34-week baby has a lower z-score. Therefore, weighs less. So the answer for the third part is 34-week baby. Okay, now example number 2. A highly selective boarding school will only admit students who place at least 1.5 standard deviation above the mean. So how many standard deviations we have? This is the definition for z-score. Z-score was number of standard deviations from the mean. So this is our z. Z is, this part is given. Z is equal to 1.5. And what else we have is this has a mean of 200, standard deviation of 26. What is the minimum score that an applicant must make on the test to be accepted? So we should solve for x. We should find that part. I'm using x. because the formula that we had, we usually use x for our data value, so that's why I have x here. The x minus mean divided by standard deviation. Z is 1.5. Mean is 200, standard deviation 26. Now solving for x, you can use cross product. 1.5 times 26 equal to 1, because here denominator is 1 times x minus 200. Or you can multiply both sides by 26 to clear this fraction. Let's multiply by 26. So this way we can clear this part. Now 26 times 1.5 is 39 equal to x minus 200. Now here add 200. So x is 239. So this is minimum score. Next page. This part we have percentiles. Here we already know that what median was. Median was what we had in between. So recall that the median divides the lower 50% of a set of data from the upper 50%. What that means, for example, if you have this part, this is 100% total. The median is in between, dividing this 100%. Here on left we have 50%, that is lower 50%, and here is upper 50%. So here we had median. So this is what that means. Median is a special case of a general concept called percentile. Because we're using all these percentages, that's why we call it percentile. So this is 50 percentile, and lower 50 percentile, and that is upper. Then here, the kth percentile denoted, we're gonna use pk. So this is over percentage, so that is kth percentile of a set of data is a value such that k% of the observations are less than or equal to the value. Let's see what that is. Here on this part, so here we have starting from 0 up to 100, exactly what I had here. So in total we have 100%. Starting from left, this P1 means 1%, so 1 percentile. This is 2 percentile, 98 percentile if I start from left. So that is 98 percentile, this is 99, then after that we have 100. But if we start from right here, what that means, this 99 is actually 1%, so this is 1 percentile. This point is 98 percentile if you start from left, so 98% bottom, but it's 2% top. So this is 2% top, and also is 98% bottom. I'm writing it for that one, 2%. That is top. And also if we move this way from left to right, that also is 98%. Now example number 3, explain the meaning of the following percentiles. Part A, the 15th percentile of the head circumference of males 3 to 5 months of age is 41 centimeter. Here is 15th percentile, but that means we have 15%. So here is 15% off. We have 3 to 5. So this group have circumference of 41 centimeter or less. We also can say %. So instead of 15%, I can say 85%. Because I have 100% minus 15% is 85%. So 85%. Rewriting this part. Now instead of having less, we have more than 41 centimeter. So this part was given was 15%, and I use exactly what we had here. So this is what we have, the highest percentage. That's why we have a number equal to 41 centimeter or less. But when you use the other side of percentile, meaning that you subtract the 100% minus 15%, now you have 85%. So that is more than 41 centimeter instead of using less. I want to write, let's make it more clear what that is. So let's say this one is P15. And here is P85. For both of these, we have 15% here, and this one is 15%. So 15%, 3 to 5 months old males have circumference of 41 centimeter or less. Okay, so these group have 41 centimeter or less. And then on this part, we have 85% of 3 to 5 month old males have a circumference more than 41 centimeter, because we have this part is more than. Part B, the 19th percentile of a waist circumference of females 2 years of age is 52.7. So exactly same as part A. Now we have 90% and also we have 10%. The same thing. Here is 90% of females. I'm writing exactly what we have here. So of females 2 years of age have waist circumference of 52.7 or less. So when it's given, you're gonna write less, and when you wanna find the percentile for the other side, meaning that you subtracting that number from 100. Now here we're gonna use more. So it's more than 52.7. But the point is that here also that is equal to this number or less, but here we have more than 41 because we already used that one. This number, okay, this one less than equal to, we use that one. I'm not able to use greater than, equal to, I only have greater than. So we have more than. Here again we have less than, equal to, and here for this part we have more than. It's like that. Now part C. On this table we have measurement of human body. One goal of this measurement is to says how body measurements may be changing over time. As you can see, we have a group of ages that we have starting from 20 to 29 up to 80 or older. And here on horizontal line we have percentile. So it's 10%, 25, 50, 75, 90%. So on this part we have height of males age 20 years or older for various age groups. So these are age group. Based on the percentile measurements of the different age groups, what might you conclude? So let's see what numbers we have here. Numbers here for 10%, 10th percentile. We have 166.8. That is for this group is 20 to 29. Going down here, these numbers are okay. Actually, this one is increasing. Yeah, it's only 0.1, so increasing. Then after that, again increases, but here decreases. So starting that point till this point is increasing, then after that is decreasing. Let's see if do we have same thing. So for all of these, we have starting from that point. This one is decreasing up to that point. So we only have one step. Here is this part decreases, increases, and okay. After that, again we have decreasing. Okay, so I'm writing these. This is increasing, then after that decreasing. This is decreasing, decreasing, increasing. Here again, decreasing. So we can say that all the numbers are increasing. As at the end, if you compare what you had on top with what you have here, that 176.7 and here is 170.5. So in total, if you want to make decision, you can say, okay, for all of these three, and obviously here, these numbers are decreasing. And this one also. So this one, just up with increasing. No, till this point. Okay, so that is increasing, then again decreasing. But in total, if you consider it's decreasing. Now consider this one, what we have for 90 percentile, because we can say if we have conclusion for this, we can apply that one for all these percentiles. So for 90 percentile, I have all these groups. And let's see what our conclusion is. So we have decreasing numbers. So this group, 80 or older. This group only had to be is 179.4. centimeter. To make 90 percentile. But for 20 to 29, for this group, it should be 186.8. So this group must be 186.8. To make 90 percentile. This implies that adult males are getting taller. So this is our conclusion. Next page. Determine and interpret quartile, inner quartile range. So inner quartile range, we're going to use IQR and outliers. Here again we have percentile, so it's starting from 0. This is what we have in between. So this is lower 50%. On the right side we have upper 50%. What we have in between, we use Q2 for that. And also you already know that what you have in between that is median. Then after that we should find what is between this smallest data value and our median. We call that Q1. And on the right side, an upper 50%. Now we should find what we have in between of median and largest data value. So this Q1 is, this is median of first half. And here Q3 is median of the second half. And the support is starting from that line up to this point. This is inner quartile range. Next part, finding quartiles. These are steps. First step, arrange the data in ascending order. Second step, determine the median. So we should find that part first. Or second quartile. So median or second quartile. Step 3, divide the data set into halves and the observations below to the left of median and the observation above median. The first quartile, Q1, is the median of bottom half. I had already that part here. And the third quartile, Q3, is the median of top half. We have these steps to find quartiles. And the next one is inner quartile range, showing with IQR that we had here on this board. And what that is equal to Q3 minus Q1. I said that is here because so that Q3, what we have for Q3 is starting from that point up to that point is Q3, and Q1 is again starting from that part to this part is Q1. Now to find what we have in between, you should subtract, so Q3 minus Q1. So I'm writing that here. So this is Q3, Q1. So to find this part, we should subtract, so this Q3 minus what you have here, Q1. That is the answer for this part. Next step, here on the spot, we want to find outliers. We worked on quartile, inner quartile, now outliers. Steps. First one, determine what Q1 and Q3 is. So we should find these two. Then after that, find inner quartile range. Now we should find, determine our fences. So finding lower fence, upper fence. This is the formula for these two. Q1 minus 1.5. We always have 1.5, so 1.5 multiplied by inner quartile range. And for upper fence, just remember when it's lower, because this is lower 50%, because it's lower, we have to subtract. And when it's upper, we should add. So that's the only difference between these two. Step 4, if a data value is less than the lower fence, or, so if less than lower fence or greater than upper fence, it is considered an outlier. Let me draw that one here. Let's say our fence is here, and if you had, this is median, and if you have points here outside these fences, so less than lower fence, this is lower fence. So this is only an example for this part. I want to only show that what that means, having lower fence and upper fence, and compare your data value with that. So this is our data value, and you can see that this data is less than our lower fence, and this data value is greater than upper fence. What that means, these two are outliers. So this is outlier, this one also is outlier. Okay, now example number 4, the following data represent the mass per gallon of a random sample. So we have random sample on this part. Part A, determine the mean and standard deviation. So mean and standard deviation. Then compute z-score corresponding to the individual who obtained 36.3 moles per gallon. So we can enter all these data into TI-84. First step is press start. So pressing start. We have this one. So you should have edit number 1, enter. Then enter all these data on this table into your calculator and one column L1. So I have all data here. So it's more than that. If you scroll down, you can see that we have more than these numbers. So this is another one for L1. So this is what I have at the end, is the largest data value is 47.5. Then after that, again, press start. So again, we have this page. Now you should choose this to calculate. So you have this. Now number 1 is Warsat. Enter. You have this. Then again, enter, enter, enter. So this is sample mean since our data was based on sample. Here is sample mean is 38.775. This is sample standard deviation, starting with S, is 3.4164. So rounding that is 3.416. Let's use that. And part A asking to find z-score. Part B is determine quartiles, meaning that we should find Q1, Q2, Q3. We already got the answers here, but I want to work on that part without using calculator. So this is Q1, this median is Q2, and that is Q3. This mean is smallest data value, max is largest data value. Okay, what if we instead of TI-84 we wanted to use StatCrunch? So this is your StatCrunch. Open StatCrunch. So enter your data into one column, and I choose to have that one L1. So you can pick any name for your variable. So we have all this data. The next step, stat, summary stat. Since we have all this data in column, so choosing this one. Now we have L1. And here on this part we have Q1, Q3. I want to have inner quartile range. So selecting all these. So that part, inner quartile range. Now I have all these that I selected on this side, right side. Then compute. Here what we have. Here mean is 38.775. We had exactly the same thing here as 38.775. Standard deviation is 3.416. 4882, let's say 4882. So on that part they rounded on StatCrunch. So exactly same thing. And what we have for median is 38.35. Median is this one, 38.35. So see, we have exactly the same thing. Q1 is 36.85, and that is 41. So 38.85. Okay, same thing, and 41 for this part. So all these are same. Inner quartile range 4.15. Okay, here we don't have inner quartile range. Let's find the inner quartile range is easy. Q3 minus Q1, that is the answer. So 41 minus 36.85 is the answer for inner quartile range. This is what we got using calculator and also StatCrunch. Now let's find the answer without using these two. But for the first part, finding mean and standard deviation, it's better to always use your calculator, as mean is easy to find, but finding standard deviation is time consuming. So I'm using 38.775 for mean, and standard deviation 3.416. We rounded this, but I'm not using that symbol for estimation. That's fine. Now finding z-score is x minus if you write x minus mu divided by sigma, that's not wrong, but it's better to use what we have here. So x minus x bar, because this is sample, this is not population, so it's better to learn which one you should use for each part. So using this. And XS36.3 minus 38.775 divided by 3.416. See, I didn't use that estimation here because at the end we're gonna round. So that is negative 0.72. What that means, here we have 0.72 number of standard deviation from the mean is that one. You may say what that negative is. Okay. When we have positive z-score, so let's add this. What that means, our data point is about the mean. But here in this case, we have negative z-score. Meaning that our data point is below the mean. This is obviously correct because as you can see, our data value here, data point is 36.3, but our mean is 38.775. Obviously, this one is less than what we have here for mean, so it's below the mean. This is 36.3, our data point, and here mean is 38.775, so it's below. That's why we got negative z-score. Next part, for B, now we should find quartile Q1, Q2, Q3. We already know the answer from StatCrunch and our calculator. Here Q1. Use these tables. Make sure that these data are in ascending order. So these are in order. So I'm starting from here, then 35.5, 36, then we have 37.5, 37.8, now we have 38.3, so all these are in order. This way, this is the first half, and this is second half. And I want to find median on this part. Median is between these two numbers. That is Q1. For Q3, median is between these two numbers. That is Q3. And Q2, here what we have 38.3, then we have 38.4. So this is median or Q2. So we should find what the answer is between these two, and between these two. Q1, 36.3 plus 37.4 divided by 2. That is 36.85 mile per gallon. Then we have Q2 or median is 38.3 plus 38.4 divided by 2. So that is 38.35 mile per gallon. And Q3 is 40.6 plus 41.4 divided by 2. The answer is 41 mile per gallon. So that is Q1. Here is Q2, and this is Q3. Now, part C, compute and interpret the inner quartile range. So finding inner quartile range, it's equal to Q3 minus Q1, 41 minus 36.85. It's 4.15. So inner quartile range is equal to 4.15. That is the difference between Q3 and Q1. So we got exactly the same number that we had on calculator and also StatCrunch. Now part E, determine the lower and upper fences. Do we have outliers? So first, lower fence. I'm using LF for lower fence. That is Q1 minus 1.5 multiplied by inner quartile range. And for upper fence, is Q3 plus 1.5 inner quartile range. So here we have Q1, this is Q3, minus plus. Q1 is 36.85 minus 1.5 multiplied by 4.15. So first multiply 1.5, multiply by 4.15, then subtract that from 36.85. That is equal to 0.625 mile per gallon. So our lower fence is 0.625. Now upper fence, we have 40 plus 1.5 multiplied by 4.15. That is 47.225. So this is upper and lower fence, and here is upper. Now we should find if do we have outlier, do we have any data value less than a lower fence and larger than what we have for upper fence. Okay, this was, so we have less than lower fence and greater than upper fence. Let's see if we have that one. The smallest data value is 31.5. This is not less than 3.625. But here we have 47.5 and our upper fence is 47.225. So this is obviously greater than what we have for upper fence. Okay, since 47.5, this is largest data value or max value. Okay, let's use maximum value. And so this point is greater than our upper fence. That's why we have outlier, and the outlier is 47.5. So the answer for this part is yes. Okay, and here we have what we have in summary. Shape of distribution. When it's symmetric, we have skewed left, skewed right. Here is measure of central tendency. We covered all these: mean, median, measure of dispersion, standard deviation, inner quartile range. So we covered all these in this chapter. And so I finished this one. I'm going to cover next section.